Hey soldier boy, can I ya trick ya trick ya?
Coming into this project, we were concerned with the direction that we see agriculture heading today.
It takes 10 fossil fuel calories to produce, process, and transport 1 food calorie. That means the average American family annually consumes 930 gallons of gasoline in their diet alone.
It may not be obvious, but a majority of the fossil fuel input for large-scale agriculture stems from the production and distribution of synthetic pesticide and fertilizer. On average, this process requires 5.5 gallons per acre.
With Hubbard's Peak predicting that we've already passed peak oil, this diet cannot be sustained.
Dickinson College prides itself in its efforts towards sustainability with initiatives such as LEED Gold certification in several of its academic buildings and its own biodiesel plant to provide fuel to many campus-owned vehicles.
The Dickinson College Farm echoes this commitment by promoting organic, sustainable agriculture in addition to energy independence.
Our goal is to continue this evolution toward fossil fuel autonomy, so we devoted this video to an explanation and documentation of how to convert a tractor from gas power to electric. On the Dickinson College farm, weeding is the biggest labor drain we face. To try and remedy this, the farm purchased an Allis Chalmers G cultivating tractor. This tractor is our candidate for conversion for several reasons.
Cultivation does not require excessive horsepower, making this tractor a good candidate for conversion. It is light and can be easily powered by an electric motor. Also, its conversion is relatively straightforward thanks to an already established conversion kit. Alright, so this is our battery mount right here. We designed and built this ourselves. It's all completed. Pretty simple. The most important thing is it's holding 80-pound batteries, so that's 640 pounds that it has to hold. So you just have to keep that in mind when you're building it. So like I said, 8 batteries. The mount is pretty simple.
So here we have our electrical components. Right here we've got wiring running from the main switch into the contactor, and that essentially opens the circuit to start up the controller, which is essentially the brain of the tractor. It controls speed. Here is the motor, and as you can see, we've wired this up all according to the instructions that were provided to us.
Down here, this is the pot box. Essentially, it just is our throttle. Allows us to control the speed, and that connects from some wiring right into the controller down here, which translates that into a signal that the motor can understand. And this right here is just screwed into the bottom of the plywood battery bank that we built, and it's a rod that comes through right up here, and that goes to our throttle up under the driver's seat.
So here we've got essentially the tractor's dashboard. We've got a battery indicator, amperage meter, and our master switch. We've got small wiring with quick disconnects connecting all this stuff.
Okay, this right here, just quick. This is our throttle. This orange piece right here, as well as the actual lever, that was from the original tractor, and it just slides back and forward. Going this rod right here goes right. It bends here. We put this piece of metal here just to get a little support, and it runs back through the pot box that we discussed earlier. We modified this tractor with a 48-volt, 225-amp system. This motor will produce 5.3 horsepower. Assuming an average load of 40 amp hours and a full charge, this tractor will run for 4.5 hours. This run time will consume 80% of the stored energy. This is important considering that completely draining the batteries would decrease their lifespan. We estimate the electric motor operates between 40 and 60% efficiency, making this model up to 6 times more efficient than the previous gas engine. Here's the motor, smaller gear right here, and there's a gear reduction, and then it just screws right in.
Next, we designed and built the battery rack to hold our 8 6-volt batteries. The battery rack is mounted using already existing tractor components, and we did not alter the tractor frame at all. We began our construction by measuring and cutting 4 pieces of angle that would be used to mount the battery rack on the frame of the tractor. To this we added a metal skeleton, which we cut and welded together using 2 pieces of angle and 5 metal strips. The end result was a 40-inch by 18-inch platform. We completed the battery rack by bolting on a sheet of plywood.
Now you can see to the right of the controller is the switch, all-bright contactor. So now what you're looking at is the speed control lever, what was and what will continue to be the speed control lever. And this is the original piece right here. This went back to the motor, the gas motor. On the old tractor, now we've bent it 2 ways, and we are going to momentarily drill down through this piece of angle, put this through it, and underneath, beyond, there's some wood. I'm just going to screw the pot box right here, this little speed controller pot box. Spring loaded, just essentially just like a gas pedal, but it's not a pedal. Screw it under there and attach this piece of metal to it. And then we're gonna have a speed control.
So we just put in some small wiring. We've got this wire that's coming from the pot box, and that's being threaded into the small terminals on the controller. Another wiring coming from the B+ terminal on the controller to one of the smaller terminal controllers. Oh, I am wiring the controller to the motor to the batteries, and as well as the contactor down here. Here we have the gauge box, or the control box, and we're putting in a battery indicator gauge as well as a gauge that will display ampage. We're going to be wiring up the on-off switch.
All right. We've got the battery bank nearly all wired up. We've got the shunt down here. This is for our amperage meter, rather. We've made the negative connection, the positive connection. This is our only break in the whole series right now. So in about 5 minutes, this thing will be running, hypothetically. So we have 1 wire connection left to make until this thing hypothetically will run. This wire, which goes to the on-off switch, hits that last connection. Okay, we have power. Aha!
Smoking purpose, drinking a Bud Light, and the 7 nooses of mine. Frank got me right, I'm running tight. 4 hours smoke.